Okay, in this problem, I've got a circle actually, or not a circle, an ellipse. So yeah, no, it's a circle. So we got a circle for the top equation, and how I know this, let me get this thing rolling here. How I know this is these x squared plus y squared. It could be an ellipse, but the numbers out in front are both 1. If they're both the same, you know it's a circle. The bottom equation is a line. And algebraically, I'm going to show you graphically as well, but I'll cheat and use use GeoGebra. Not that that's cheating. We're just using the tools at hand. But we'll check our answers. So we'll do algebra and then check our answers with technology. So first step is we're going to use substitution. So we're going to solve this bottom equation here for y. So to solve that, I'm going to subtract the 2x over to the right. And so y equals negative 2x minus 1. And again, I just put the 2x first and the 1 second. So now I'm going to take this negative 2x minus 1 right here, I'll do this in blue, and substitute it wherever there's a y. And there's two places where there's a y, here and here. So it's got to go in both places. So x squared plus, and instead of a y squared, we're going to go negative 2x minus 1. Plus 3 times negative 2x minus 1, and then it equals 22. Okay, so there's your first substitution. Now when we solve for x, we'll have, and this should be squared. I screwed that up because that was y squared. So when we solve for x, we'll get the where these two, this line and the circle meet for the x values. So the first thing then, we got to simplify this expression. So plus, and this is negative 2x minus 1 squared, plus, and then you want to distribute the 3 through. So that would be plus a negative 6x minus 3 equals 22. So now here we'd FOIL, or distribute as I'd rather call it. First outer inner last for FOIL, because FOIL works as long as you have a binomial. But without a binomial, you got to use something else, which is it's just distribution. So that would be 4x squared plus 2x plus 2x plus 1. And then the rest of the equation, minus 6x minus 3 equals 22. Now we're going to move everything. Since this is an x squared, we're going to add stuff together. So x squared and 4x squared is 5x squared. 2x and 2x and 6x would be negative 2x. 1 and negative 3 is minus 2, and that equals 22. Since it's an x squared, we're going to move everything left, put in descending order, and either factor it or use quadratic formula. Or complete the square if you wanted to. And so I'll subtract the 22 to the left, and you'd have negative 24 equals 0. Well, this thing factors. And so, I teach a set of kind of guess and check factoring instead of a formula. You could use quadratic formula on this, but since it factors, it makes things a little quicker. So 5x squared, you got a minus and a minus, which would be minus plus. 5x squared breaks into 5x and 1x. That goes in the front. And then the 24 in the back, you could use 8 and 3, 6 and 4, 12 and 2. And I'm looking for a negative 2 when you have a sum of the negative and positive there. So, 5 times 2 is 10, and 12 has a 2 difference. So let's put the 12 here and the 2 here. And if you check that, you could FOIL it all the way back through to check it, but all you need to do is check the middle 2 and the outside 2. And that's negative 12x and 10x, which is negative 2x. So we know this checks out, kind of using FOIL with just the O and the I in that. So next step then is to set both of those to 0, since we know we factored it right. So 5x minus 12 equals 0, and x plus 2 could equal 0. Either one of those are solutions to that equation. So if you add 12 over, you'd have 5x equals 12, and then you divide by by 5 on both sides. And so one of our x values is x is 12/5. On this side, you just subtract 2, and we know our other x value is x is -2. So now we need to find out the y values, because we're really looking for a geometric, an ordered pair where they intersect. So I'm going to use that original equation, which was 2x plus y equals -1. I'll write that up here. And solve both of those. We'll use substitution again. So instead of 2x, I'm going to have 2 times -2 plus y equals -1. You solve that and you'd have -4 plus y equals -1. And so y is equal to 3 because you'd add the 4 over. And so we know that this line and this circle intersect at least this point, -2 and 3. So we'll check that in GeoGebra to make sure. The next step is to plug in the 12/5. So 2 times 12/5 plus y equals -1. And so you'd have 24/5 plus y equals -1 minus the 24/5. And so -1 minus 24/5. Well, -1, we need a common denominator. -1 is the same as -5/5. And so that would be -29 29/5. So this ordered pair would be 12/5 comma -29/5. And again, that's an improper fraction. So let's convert that to a proper fraction, which would be 1 2/5, or 1.4, and -5 4/5, or which would be -5.8. So let's see how close we came. So I might have to talk a little louder as I move to another spot here. But so if I plug that equation in, 2x plus y equals 1, -1. I do believe that's the correct one there. We'll just double check. Yep, 2x plus y equals -1. And then we need x squared, and I'll put that in the bottom, x squared plus y squared plus 3y. So x squared plus y squared plus 3y equals 22. And there's my circle. And I'm going to zoom out just a little bit so we can see that. So zoom out, there we go. And then I will go over here for a new point, but I want to intersect two objects. So I'll click that, hit our circle, hit our line, and A and B should be our answers. And there they are, 2.4 and -5.8, and -2 and 3. And so we've just verified it's correct, and we're done. So I hope this helps you figure these out. Good luck, and see you next time.